All right, so today we're going to learn how to find the absolute max and the absolute min of a function without the graph. We're going to do it analytically. And I was just saying, the kids were asking about their tests, and I said, so far it seems like this class, period 7, has done better than any of the other classes. And then they told me it's because they got all the answers from the earlier. And I said, oh, so that's what happened. Okay, so yeah, I'll try to get those scores up there. Is there anyone else has to make arrangements with me to take the makeup? So when are you going to do it? I know, it's amazing. I heard you were here. Oh, I'm recording this. Oh, you should take this test on Thursday. No. No. No, like in general. Okay, today we're going to be talking about how to find the absolute extrema of a function, and really over a closed interval. And so what I want you guys to think about now for a few minutes is, I've labeled the absolute min, the y coordinate that's less than or equal to all the other y's. Local max. This y coordinate here is greater than the y's in a neighborhood around it, but it's not the greatest y coordinate. That's why we call it a local max. There's another word we can use for local where you say relative. It's weird. They have two words for each of these. So this would be either a local or a relative max. This would be called an absolute min, or sometimes they refer to it as a global min. So global and absolute mean the same thing, and relative and local mean the same thing. But look at, bless you. So look at where these occur and see like if you can come to any conclusion as to different possibilities, like as far as where they can occur. Well, think about it for a second. Look at what you got. And I want you to look at, I've labeled the absolute max and the absolute, the plural is minimum or maximum. I mean, the singular is minimum or maximum. When you make it plural, you make it maxima or minima. Okay, but you can see where they all are, and I want to see if we can come to some kind of conclusion about where they can occur. Anyone want to? All right, Jess. Okay, sometimes they occur where there's a horizontal tangent. So what does that mean about the derivative? 0. So where can they occur? They can occur where the derivative equals 0. Very nice. And the other places, because that would take care of this one and this one. Where else can they occur? Yes, Henry. Okay. So where the derivative doesn't exist, right? Very good. So they can occur where the derivative does not exist. And that would take care of this guy up here. Where's the last place they could occur? Yes. Well, it's not really a vertical tangent here. These are the ones we got to hit. What are these points here? Endpoints. So are you going to say? Oh. Oh, well. You could have said yes. Oh, okay. I thought you did. Yeah. All right. Are we clear on the difference between a local or relative extrema and an absolute? To be an absolute maximum, it has to be greater than or equal to all the other y coordinates. To be a relative max, it just has to be greater than the y's in some neighborhood around it. Right? It's like the big guy on campus, but not in the world. Okay. I have a little slideshow I just need to go through with you. I'm trying to clarify this. I think you're going to like it today. It's kind of a nice, easy-going day. Good. Well, I don't know. Did I open this way too many times? Let's see. I hope this is the right one. I just want to make sure this is the right one. Yes, this is. Okay. So, from the beginning. In pre-calc, you guys used to find the max, find the min using your calculators, right? You graph it, and we're going to be able to find these values without the calculator, without graphing it. We're going to find these analytically, not graphically. It's so exciting. By hand, yeah. Yeah, so we can use the word global. We usually use the word absolute, but they can be used interchangeably. Get to the good stuff. And we said extreme is just the plural. Extremum. Extremum could be either a maximum or a minimum. All right, first example. So extreme values, we said, could either be at interior points where the derivative is 0 or undefined, or at endpoints. Well, here this is not a closed interval. So if you look at this y equals x squared, it goes on forever. Is there an absolute min? Yeah, what is the absolute minimum value? 0. Okay, the smallest y value would be 0. It occurs at x equals 0 also. Is there an absolute max, a y value that's greater than or equal to all the other y's? Nope. So this one only has an absolute min, but doesn't have an absolute max. So we change it up a little. Maybe just look at part of it. So now we have it over a closed interval. Now is there an absolute min? And what is it? Still 0. And what about the absolute max? Well, the absolute max is 4. It is the y coordinate, but it occurs at x equals 2. Okay? Yes? Yeah. There is no relative or absolute. Today we're only going to find absolute extrema, but there was no relative max, because if you look back at the last one, I'll just draw it down here because I don't know how to do that. Well, it kept going. There's no y coordinate on that graph that's greater than or equal to all the y's in some neighborhood around it. Like if you look, I should go back. Let me go back to that. Previous. No, I want you to see that. So what happened? Previous. Okay. See, in order to be even or just a relative max, there would have to be some interval where that y coordinate was some open interval where that y coordinate was greater than or equal to all the other y's. All right, so you're looking, there is none. This can go up higher and higher. But here we have an absolute max of 4, which occurs at 2, and an absolute min of 0, which occurs at x equals 0. I don't want to go too fast here. Next. Now, we still have an absolute max. Right? Still 4. It occurs at 2. What's the absolute min. Is there a y coordinate that's less than or equal to all the other y's? This one always bugs the kids. All right, what is the absolute min? What is the y coordinate on this graph? Oh, you can't use limits. You got to give me an actual y value. No cheating. If you could, but we have to come up with a y coordinate. And a lot of people say, well, it's the y coordinate right after 0. But whatever you tell me, think of the number line. Just let me draw on this. But between any two numbers on the number line, there are an infinite number of numbers. So no matter what y value you could give me, 0.00000000007, there's a y coordinate that's less than that. And you can't use a limit here because it has to be, it can't be just approaching it. I mean, I guess that would be, I understand what you're saying there, but to be a minimum of a function, it actually has to be a point on, the y coordinate of a point on that graph. It's not. What about here? There's no absolute max, there's no absolute min. Right? We do understand that, it is approaching that the limit exists on both, but can't use it. All right, so no min, no max. So all this is leading us to something called the extreme value theorem. The extreme value theorem is basically a guarantee. And it says as long as the function is continuous over a closed interval, you got to have those two criteria met, then it will have a maximum and it will have a minimum value. But it's got to be continuous over a closed interval. It's got to contain the endpoints. Oh, and this is just a guarantee that it will in this case. Just because it's not continuous doesn't mean there won't be a max or a min. It's just saying that it's guaranteed to have a max and a min if it is continuous over a closed. All right, that's a really good point. And so sometimes the absolute max can occur at an interior point where the derivative is 0, right? Absolute min is at an interior point. Or we said they can occur at endpoints. You could have one of each. You could have one at an endpoint and one at an interior point. Yes, Tim? Okay. So you're saying like we had before, like it was going up to 4, but it never got there? Yeah, so that one didn't have an absolute max. There was no y coordinate of no specific y value you can state that's greater than or equal to all the other y's. Because it has to be a finite value. Okay. Now, as far as local or relative extrema, okay, we said that those can occur either where the derivative is 0 or where the derivative is undefined. Oh, and if it is an absolute maximum, it's also a local or relative. So we got what isn't. So yeah, and we really use the word relative more than we use the word local. You want to know both words for both. Now, so as far as the interior points where the absolute extrema can occur, we said, or relative, it has to be where the derivative is 0 or undefined. And these places are so important, we gave them a name. Here it comes. Critical points. So you need to know that a critical point is any point where the derivative is either equal to 0 or it's undefined. They're critical because that's where you might have a max or a min. You can't have a max or min anywhere else other than the endpoints, except at a critical point. So it's where the derivative is 0 and defined. But just because you have critical points, it doesn't mean you're going to have a max or a min there. But it has to be a critical point to even be a contender. So we need some steps. How do we find the absolute max and the absolute min values? Well, and when it says analytically, that means without using a graph, okay, without the calculator. So you're just going to be given a function. They'll say find the max, find the min over some interval. So the first thing you want to do is you want to get the derivative and get your critical values. Find out where the derivative is 0 and where it's undefined. When is a fraction going to equal 0? Yes, Cameron? Yeah, if it's a fraction, is it the numerator or the denominator that has to be 0? For it to be equal 0, the numerator equals 0. To be undefined, the denominator is 0. So that's when your derivative is going to be undefined, when it looks like a fraction. Okay? Any value of x that makes that denominator 0, that's where it's undefined. Any value that makes the numerator 0, that's where it's 0. So you want to find those critical points, critical values first. And what you want to do is get the y coordinates at each one of those. So you're going to pop those into the original function and get the y coordinates at each of the critical values. Now, we might have a max or min at the endpoint, so the next thing you have to do is get the y coordinates at the endpoints. So you'll know the y coordinates at each of the critical points. You'll know the y coordinates at the endpoints. All you got to do then is just compare. So compare the functional values. This guy somehow got cut off right here. So compare the functional values. Compare the y values that you found at the critical values and at the endpoints. The absolute min is the least of these. The absolute max is the greatest of these. Yeah, that's what got cut off. So we're going to do one together, and then we'll go and do one part. So we have this function f of x equals x to 2/3. And we want to find the absolute max, the absolute min on the interval from -2 to 3. What do you think the first thing we have to do is? Find the derivative so we can find our critical points. What's the derivative of x to the 2/3? 2/3 x to negative 1/3. Now, yeah, or if you wrote it the other way, it'd be 2 over cube root of x, okay? Now, is the numerator ever going to be 0? If it's 2 over 3 times the cube root of 0? No. But is the denominator going to be 0? Yeah. So we'll have a critical value, okay? We have a critical point. So if it's going to have a max or min on the interior of the interval, it's going to be at what x value? 0. That's the only critical value. Okay, so this is not defined at 0. All right, so now, so we have one critical value, x equals 0. Now we're going to have to get the y coordinate there. To get the y coordinate, you plug it into the original, and that's 0 to the 2/3 is 0. Okay. Now we're going to check out the y's at the endpoints. So if you plug negative 2 into the function, negative 2 to the 2/3, how do you do something like that? Negative 2 to the 2/3. Well, if you don't have your calculator, say. Yes. You got it backwards. Power over root. So say it again now. Yeah, so it'll be the cube root of negative 2 squared, or the cube root of 4, right? Now, this was done with a calculator. So, yeah, when we plugged in 0, we get 0 for y. We plug in negative 2, we get the cube root of 4, which is like 1.58 something. Then we plug in 3. So you can take the cube root of 9, and that turns out to be a little over 2. Oh, they went too fast with that. So you look at these y values. You have, at the critical value, the y is 0. At one endpoint, the y coordinate's 1.5 something. At the other endpoint, it's 2. Of these three y values, which is the minimum? Which is the least? 0, right? So the absolute min is 0, and it occurs at x equals 0. Yes, that was our critical. That's when the derivative was undefined. Okay. So we're technically, I know it says it's giving you the point. If they just say what is the absolute minimum, you really should just say the y value. The absolute min is 0. It occurs at x equals 0. And then the absolute maximum is 2.08, which occurs at x equals 3. Oh. Now, if you were to graph this on your calculator, if you actually put in x to the 2/3, and you set your window from negative 2 for your min to 3 for your max, you'll actually see that what we found is correct. There is an absolute min of 0 at x equals 0, and there is an absolute max of 2.08, or the cube root of 9, at x equals 3. So we didn't have to have a calculator, to know where the absolute max and the absolute min was. We could do it just by checking out the y's at the endpoints and comparing them to the y's at the critical values. Oh, yeah, I have to show you one other thing, then we're going to try one. But just because you have a critical point, I just want you to realize you might not have a max or min there. A couple of classic examples. Well, our old friend, y equals x cubed, right? What would the derivative be? 3x squared. What value of x makes that 0? 0. So you have a critical point at 0, right? The derivative, the slope of the tangent is 0 there, but is it a max or a min? No. So, not extreme. Same thing with another classic, the cube root of x. If you took the derivative 1/3 x to negative 2/3, it's undefined at 0 because you have a vertical tangent, but it's not a max or a min. Okay? It's just that if you're going to have a max or a min, it's going to occur at a critical value if it's at an interior point. Perfect. Exactly. Think of subsets, right? Like, you can, I can't write on this, but yeah. Pretend. So, okay. All right, now we get to have some fun with this. Thanks. I panicked. I panicked. Wait. Okay, it's still recording. I didn't panic, kids. All right, now we are. So let's do an example. Let's go through an example ourselves. Let's actually. So we want to find the extrema, and I'm talking about the absolute extrema of this function on the interval from -2 to 3. And when we're done, we'll check it out on our graphing calculator. But let's do it all without the calculator. So what should your first step be? Get the derivative. I need a bigger screen. We want to find those critters. That's what my calc teacher used to call them, critters. So we got to find out if there are any x's that make it either 0 or undefined. That's because that's how we get. You can call them. I don't like really calling them critical points, although that's what they call them. But critical value seems better because it's just the x value. But it doesn't matter. So you want to know where the derivative either equals 0 or where the derivative does not exist. Critical value. There are going to be values that make the derivative equal 0 where we will have horizontal tangents, right? How are you solving this? Okay, and then what? Factor 3x. What do you got in here? X minus 2. So we factor when we try to solve equations equal to 0 because the product equals 0 when any of the factors is 0. Is 3 ever going to equal 0? No, so don't write x equals 3. All right, what about the next factor? X equals 0. And when will x minus 2 equal 0? So we have two critical values right there. Are there any values of x for which the derivative will not exist? You try to plug it in, and it's like, what the? I'm dividing by 0. Is there any value of x that you're not allowed to plug in? No. So we don't get any there. I'm doing a little empty set there. You don't have to do that. I mean, the only time you're going to get those is when the derivative looks like a fraction, right? Okay, so now what should we do? We got our critical values. Into what? We know if I know if I plug them into the derivative. Oh, wait, you're talking about the endpoints. Oh, okay. Okay, we could do that. So you're saying find the y coordinates at the endpoint. All right, that's like my step 3, so I'm going to write. That's right, you're going out of order. That's cool. All right, so we have to find out what is f of -2, the y coordinate at one endpoint, and the y coordinate at the other endpoint. All right, see if you can do that without a calculator. What do you get if you plug -2 into the original, into the function? Couldn't help it. You had to go for the calculator. -2 cubed minus 3 times -2 squared. You got 0? You got -20. All right, I like that better. Yeah, because -8 minus 12, you got to do the whole PEMDAS thing. -20. How about when x is 3? 0? Okay, yeah, that's right. I'm improving that. All right, so we know the y's at the endpoints. We know where the derivative is 0 undefined. What else do we have to get? Yeah, so we got to plug these into the actual function. We have to know the y coordinates at the critical value, so it's 0 and 2. That's like you don't have to label your steps. I just did that because for the kids trying to follow along at home. Into the function, not the derivative. What's f of 0? Excellent. What's f of 2? -4? Okay. So these are the y coordinates. Are we going to compare? We got 0, -4, -20, and 0. Of these, which is the absolute maximum value? Okay. Well, it occurs at 2 different places, but what is the absolute max? Yeah, the absolute max is 0, but it occurs at two different places, right? It occurs at x equals 3 and x equals 0. At x equals 0 and x equals 3. So the absolute max is 0. That's the absolute greatest y value this graph attains. What's the absolute min? The absolute min is the y coordinate, right? So negative 20. And it occurs at x equals negative 2. Now, I wonder if this is right. We did this all without a calculator. Let's put this into the calculator, graph it. When we set our window, I already know x min should be negative 2 and x max should be 3. Y min, just some number less than 0 so you can see it. Oh no, less than negative 20, I'm sorry. And y max, a number a little greater than 0. What? Yeah, I set my min and max negative 2 and 3. My y min, I made negative 22. I just went a little below it. Y max 2. Does this back up our results? Right? You see it has a minimum of negative 20, which occurs at negative 2, and a max of 0, which occurs at both 0 and 3. Okay? So we're just finding absolute extrema. There is a relative min over here, but we're not getting those yet. We'll talk about that later. But at this point, you want to be able to find the absolute max, absolute min values without a calculator. You know, this is good to verify it. You think you guys can do one? You do? I don't know. All right, so try that next one. No, I'm not going to open the window, Jillian. What about other people? Okay. All right, I'm doing that. I'll pause it for a second. All right, what's the absolute max? Give me the y value, the absolute max. 16. And what about the absolute min? Negative 1. Oh, you got 0, huh? Ooh. Sydney doesn't know what's going on. Yeah, what's that about? Yeah, so there were two critical values, x equals 0 and x equals 1. Seemed like you guys were doing great at that. So you had to get the y coordinates at each of those, 0, negative 1. Then you had to check out the y's at the endpoints. You got 7 and 16. You look at them, 0, negative 1, 7, 16. Absolute min, negative 1. Occurs at x equals 1. Absolute max, 16. It occurs at x equals 2. Do we love it? And anyone look at on the calculator, see if it was right? You believe it was. Why isn't 0 an answer? Because when you compare 0 to negative 1, you know. All right, so let's just, so we're not going to look at the graph, we just believe it. All right, that's fine. We can just believe it. Well, yeah, we'll talk about the homework in a second. What's the first step when you want to get the absolute extrema? What do you got to do first? Yeah. Very last page. Well, except for the homework. Now, you get the derivative, and what do you got to do once you get the derivative? Right, so you're going to find your critical points. Critical points, and that's where the derivative either equals 0 or the derivative does not exist. Because that's where you might have a max or min. That's where you got to find those. All right, so we get our critical values. Then what? Say it again? Right, right. Plug each of the critical values into the original function. You can word this the way you guys want to word it. Each critical value into the function. not the derivative. All right, so now you know the y coordinates, the critical values. Then what do you got to do? Yeah, find the y coordinates at the endpoints. So plug the endpoints into the function. Plug, I'm just going to write, all right, I'll write, say, plug A and B. Ooh, I could actually just say find f of A, find f of B. That would be even better. A and f of B. So now you know the y coordinates at the endpoints. What's your last step? You just compare them, right? Take the greatest, that's your absolute max, and the least is your absolute min. So compare, you know, the greatest I started to say greatest is, and I don't know what happened. All right. Something I just kind of, greatest, est, holy mackerel, what is going on here? All right, let me try that again. And I was thinking as I was starting to write it, this is too obvious, but I better write it. Right is the absolute max, and the least is the absolute min. Is the absolute min. Okay. As far as the homework goes, on the first side, I said optional, you don't have to do that one with the absolute value. On the second side, what do you want to do, the odds or the evens? All right, do whatever you want. Just do half of them on the other side. You'll get the point by then. On the other side? Yeah, like do the first side except for that number 3. And then the other side, do either odds or evens. If you No. No, I just think, you know, you probably get it. You know, it's not, I think you guys get it. All right, that's the end.